3 now, we are going to relate the value of p of a to the remainder of p of x divided by x minus a. So we're asked to do two things in example 3. The first thing that we're asked to do is to show that the remainder of f of x, so we divided by x plus 2 is equal to f of negative 2. So I need to find two things. So first of all, I need to divide by x minus 2. And then the second thing that I'm asked to do is I'm asked to find f of negative 2. All right, so let's work on the first one. We're going to use synthetic division because that has been the fastest method so far. Dividing by x plus 2, so I'm going to put a negative 2 in the little box. I look at the coefficients of f of x and realize that all the powers of x are represented. I have an x cubed, an x squared, an x, and a constant 5, so I'll put those coefficients in. 1, 8, 12, and 5. Then I'm going to draw an addition sign. I'm going to bring down that number 1. 1 times negative 2 is negative 2. 8 minus 2 is 6. Well, 8 plus negative 2 is 6. And then negative 2 times 6 is negative 12. 12 plus negative 12 is 0. Negative 2 times 0 is 0. And 5 plus 0 is 5. So when I divide f of x by x plus 2, I'll get x squared plus 6x plus 0. You don't have to write the plus 0, but it's there, with a remainder of 5. And it tells me that something's happening with the remainder here, so I'm just going to highlight that and we'll see what's going on. All right, so then it says find f of negative 2. All right, so let's find f of negative 2. To find f of negative 2, I'm going to need to substitute in substitute a negative 2 for each x. So I will find f of negative 2 by substituting in negative 2, so negative 2 cubed plus 8 times negative 2 squared plus 12 times negative 2 plus 5. All right, that is not something I can do in my calculator. Sorry, that's not something I can do in my head. I definitely want to grab my calculator, so I'm going to go grab my calculator, type all of that in, and when I type it in, I'm going to get that f of negative 2 equals 5. Wait a minute. That's the same thing as the remainder. So that brings me to the remainder theorem. The remainder theorem says that if you take a polynomial and you divide it by x plus a, the remainder is the same as p of a. So that's nice to know, because if I don't want to go grab my calculator and type in, where is it? If I don't want to grab my calculator, I don't want to type all this in. That's kind of annoying. Or maybe even I don't even have access to a calculator. For you might be taking a non-calculator portion of a test, or you just don't want to. I can use the remainder theorem and do synthetic division, and these numbers are much smaller and easier to handle. So we're going to use the remainder theorem. So that brings us to example 4, where we use the remainder theorem to evaluate some polynomials. It says a technology company uses the function r of x equals negative x cubed plus 12x squared plus 6x plus 80 to model expected revenue in thousands of dollars for a new product, where x represents the number of years after the product is released. Use the remainder theorem to estimate the revenue in 5 years. So this is what they're asking me to do. Use the remainder theorem, estimate it in 5 years. So that means they want me to find r of 5. Well, I could substitute 5 in for all the x's, or I can use the remainder theorem. So I'm going to use the remainder theorem. If I'm finding r of 5, then I'm going to put a 5 right there. And then I notice in the polynomial, all the powers of x are represented. So here are the coefficients, negative 1, 12, 6, and 80. Plus sign, carry everything down, carry down the first number, 5 times negative 1, that's the arrow by the way, 5 times negative 1 is negative 5, 12 minus 5 is 7, 5 times 7 is 35, 6 plus 35 is 41, 5 times 41 is 205, and 205 plus 80 is 285. And remember that X is, not X, it's the revenue in thousands of dollars. So $285,000 is my expected revenue in 5 years. So expected revenue is $285,000 in 5 years. All right, then we have something called the factor theorem. The factor theorem is a way to figure out if a binomial is a factor of the polynomial. So eventually we're going to get to a point where I'll say, hey, here's a polynomial, factor it. And all the methods you've tried before, like factoring by grouping, or factoring the trinomial, or sum and difference of cubes, all of those methods don't work. So you'll need another method to factor. So one thing that you're going to use is the factor theorem. So this is kind of getting you in the frame of mind to start thinking about the factor theorem. So the factor theorem says that an expression x minus a is a factor if you divide the polynomial by it and you get a remainder of 0. So let me talk about this with numbers. So 18. Let me take the number 18. I know that when I divide, that 9 is a factor of 18 because I know, and you know too. I can divide 9 into 18. But 9 is a factor because when you divide 18 by 9, you get 2, and there's no remainder left over. Same thing goes with algebra. So I'm going to do that here. Is it a factor? We're going to see. So I'm going to divide by 4, 1, negative 10, 28, negative 16. Let's do some synthetic division here. I'm adding 1, 4, negative 10 plus 4 is negative 6. 4 times negative 6 is negative 24. And I add those, I get a positive 4. 16, I get a remainder of 0. So what am I trying to answer? Is it a factor, yes or no? Yes. X minus 4 is a factor because the remainder equals 0. So what that means is, if I were to take the p of x, x cubed, minus 10x squared, plus 28x, minus 16, and I were to say, hey, factor that so-and-so, factor that Sally, factor that Donnie, I could say I know for sure that's going to factor into x minus 4 times something, and there'll be no remainder. Now it'll be up to you in later lessons to figure out what that something is, but for right now, you just have to be able to determine if it's a factor or not. All right, and I think that concludes our lesson for today.